Welcome back, Algebra 1 students. We are still in Chapter 5. Today we're looking at a new section. This section is the transformation of functions. We are still specifically looking at the absolute value function. Remember, the absolute value function makes that V-shaped graph. So today in this first lesson for section 4, so this is 5.4a, our learning target is I can graph a function rule using translations of the parent function. So our function rule that we're looking at specifically is the absolute value function, but these techniques that we're learning, the success criteria that we're learning is applicable to all functions. But we're specifically looking at the absolute value function today. And then also we will be analyzing these graphs as well. And we talked about how you analyze these graphs before. You find the domain, the range, the vertex, the axis of symmetry, and also we looked at rate of change in the last lesson. So what is a transformation? Well, a transformation can be a translation, and what this is, it's a shift of your graph. So here's your parent function graph here. So you can shift it up and down or side to side. So moving this whole graph up, down, or side to side. That would be a translation. And of course, the parent function we've talked about is that basic, simplest form of a function. So down here, this is our parent function for absolute value. So we're looking at the function of the absolute value of x right here in this graph. So if you notice, your vertex of the parent function is at the origin 0, 0, and the slope of the graph is 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So there is your parent function. So let's just make a note. This is the parent function of the absolute value. Which is given by f of x equals the absolute value of x. All right, so let's look at some translations. Let's, let's look at how this parent function can be translated. Remember, translation is up, down, or side to side. So we're just going to make some observations for now, and then we'll put all our findings together for our success criteria. So look at this one. I have g of x equals absolute value of x plus 2. So from the parent function here, where the vertex is at 0, 0, so that's where the vertex started, at 0, 0 here. Now the vertex moved up 2. This whole graph moved up 2, translated up 2 units. So let's make an observation. If you add a number of units outside of the absolute value, that's moving it up. Let's look at this one. Absolute value of x plus 1. So our parent function starts at the origin 0, 0. This we see our vertexes here moved up 1 unit. Let's look at this one. Absolute value of x minus 2. It went down 2. And then the last one, absolute value of x minus 3. From the origin, it moved down 3. All right. So here's our success criteria. Let's put these findings together here. If you have the absolute value of x plus k, so k would be whatever number you're adding, that's going to translate the graph, the parent function, by whatever that k is, by k units. If you had absolute value of x and then you subtracted a number, we'll call it k, that's going to move this parent function down by k units. All right, moving on. Let's look at some more of these. All right, again, we're starting with your parent function. This is just to remind you what the parent function looks like of the absolute value. F of x equals absolute value of x. So let's look at this one. Let's make an observation. Now we're adding a number inside the absolute value. Before, let's just go back to the last page real quick. Before, we were adding outside of the absolute value, and that moved it either up or down. Now it's inside the absolute value. When you're adding inside the absolute value, look at it, moves it over to the left. So this went left 2 units. Let's look at this one. You're adding 1 inside the absolute value. What did that do? It moved it over 1 to the left. Okay, let's look at this one. This is subtracting. When you're subtracting inside absolute value, it's moving it over 2 to the right. How about this one? Subtracting 1 inside the absolute value moves it over 1 to the right. All right, let's put that together. Success criteria. Remember, SC means success criteria. So if you are subtracting inside absolute value, that's going to translate this parent function to the right by h units. And if you're adding inside the absolute value, it's going to translate that parent function to the left by h units. Okay, moving on. Next page. Let's put it all together. Let's put these horizontal and vertical shifts all together. So let's look at this example. So this -4 inside is going to move it to the right. It's going to go right 4 units, right 4. This -2 on the outside, when it's on the outside, it's either going to go up or down. And since we're subtracting, it's going to go down 2 units. So here's your parent function. Right here, here's the parent function. I'll highlight it in pink. That's what we start with at the vertex of 0, 0. And we're going to move that vertex right 4. 1, 2, 3, 4. And then down 2. 1, 2. So there's my new vertex right there at the point 4, 2. So my new vertex is at 4, 2. Now notice, if you look at the original equation, this h value here, this h value changed signs. Right here it was -4 or -4 maybe, and then you changed it to +4. Oh, this should be -2. We went down 2. Whoops. Okay, and then this -2 stayed the same. So you changed the sign of this one, keep this sign the same. And then your axis of symmetry is right here at x equals that number 4. All right, let's do another one. Pause the video, try this one on your own. All right, number 10. So this plus 3 is going to move it to the left 3, and this plus 5 is going to move it up 5. So left 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. There's your new vertex right here at -3, 5. Again, notice how your sign changed here and it stayed the same here. And then here is your axis of symmetry at x equals -3. All right, let's summarize that. Let's put it all together. Put all our success criteria together. Here's all the success criteria. So the value of h here, if it's inside, value of h is inside the absolute value, then that's going to move it either left or right. It's going to move it left if you're adding inside. It's going to move it right if you are subtracting. And then this k value, when it's on the outside, it's on the outside of the absolute value, then, let's put an x in there because it kind of looks like an 11. If it's on the outside of the absolute value, then it's going to move it either up or down. It's going to move it up if you're adding, down if you're subtracting. And then the vertex is given by hk. Remember, you're changing the sign of that. So this is the opposite sign. And then this sign stays the same. Same sign. Okay. And then, of course, the axis of symmetry is that k equals h. Whatever this value is, that's what you put here. X equals, and then whatever that value is from your vertex. Finding the vertex and axis of symmetry. So how can you find it without even graphing it? Well, if you look up here to our success criteria, we saw that you can just look at the equation and find the vertex by changing the sign of what is inside the absolute value and then keeping this sign the same. So here's my h and here's my k. I want to change the sign of my h so that becomes +2 and keep k the same. So the answer is 2, 6, and this is the vertex. Now we're going to find the axis of symmetry. I'll call that A. And that's going to be x equals, it's always x equals, and then you use this value, the x value from the vertex. So x equals 2. Go ahead, pause the video, answer the next 3. All right, let's check your answers. For number 12, your vertex is -5, -9. Change the sign, keep the sign. And then the axis of symmetry is x equals -5. 13, your vertex on this one, there's no number inside, so that's just going to be 0. 0, and then -8. And then x equals 0 for your axis of symmetry. Vertex on this one is -7, 11. And then your axis of symmetry is x equals -7. And that's all I have for you today.